All right, let's talk about light, interference, and how we can see the universe in a whole new way.
This right here, this is LIGO. Think of it as a giant ear listening to the cosmos.
And when I say giant, I mean it. Its arms are 4 kilometers long.
But check this out. It's built to measure a change in length that is just mind-bogglingly small.
So how in the world do you measure something that tiny?
The answer, and it's a clever one, is all about a property of light called interference.
So, what's interference? It's just when two light waves overlap and their energies add up.
If the waves line up just right, things get brighter. If they're out of sync, they can cancel out completely. And that creates these cool patterns of light and dark, kind of like the rings you're seeing here. And get this, a brilliant device from way back in the 19th century was made to control this. It's called the Michelson Interferometer. It splits light, then puts it back together to see the result.
So you split a beam, send them on different paths, bounce them off mirrors, and recombine them. Simple.
Okay, so how does this old-school gadget connect back to LIGO?
Well, LIGO is basically just one of the biggest, most sensitive Michelson interferometers ever built.
And those super long arms? They're tuned for one very, very specific result.
The returning laser beams are set up to perfectly cancel each other out, which means normally no light ever reaches the detector. It just sees darkness.
But then, a gravitational wave from deep space comes passing through.
It actually stretches one arm and squeezes the other just by a tiny, tiny fraction.
That tiny change is just enough to knock the light waves out of perfect sync.
And suddenly, a little flicker of light hits the detector. That's the signal.
So light interferes. We use that to measure tiny changes. And LIGO sees cosmic ripples as flickers of light.
You know, they said this would open a new window to the universe. And boy, were they right.
So you gotta wonder, what other cosmic secrets will this elegant principle of light help us find next?